Okay, so we are going to be working on 2B from the Cambridge textbook. We are going to be learning to solve literal equations and simultaneous equations. So the first question we've got is x over a plus x over b is equal to a plus b. So because we're dealing with letters, it makes it a bit harder. So the same rules apply with numbers. So to get our denominators the same, we are just going to times them by the opposite. That means I'm timesing my right hand side by b, and I'm timesing my left hand side by b and my right hand side by a. So you're going to rewrite that. I'm left with xb over ab plus xa over ab is equal to a plus b. I can write that as one fraction. Now, I hate fractions. We try and get rid of them as quick as possible. So here we've got a dividing line of AB. So I'll take that to the other side. Just be mindful on when you do that, you have your brackets around AB. So that gives me XB plus XA is equal to AB over A plus B. So the next step that we are going to be doing here is we are wanting to get X by itself. So I'm just going to factor out the X value. Now I've done that, it makes it easy. I'm just going to take over b plus a to the other side. As soon as I've done this, I can see a relationship where b plus a is the same as a plus b. So I can cancel them out, and that leaves me with x equals ab. Next question I've got is we're going to solve the following for x. We've got bx minus a over c is equal to cx plus a over b. So with this question, the same as what we did before, but this time, because of the equal sign, when we times it by c, we can cancel the c out. When we times this side by b, we can cancel the b out. So that means I can rewrite it as b over b in brackets bx minus a, c in brackets cx plus a. Before we do anything else, we just need to expand. So that means I'm going b times bx and b times negative a, c times cx and c times a. That gives me b squared x minus ab and c squared x plus ca. The next part I want to look at is how can we simplify? So this is where I would be getting all my x's to one side. So this is why I took c squared x onto the other side, and that gives me b squared x minus c squared x minus ab equals ca. Is there any terms that don't have x? Yes. I take that to the other side by plussing. Now I've just got x by itself. When each term have got x, we factor it out, and then I can divide. So I will divide by b squared minus c squared. Now, we can still finish this off. So on my numerator, I can clearly see that I have something that is common, and what is common here that they both have a. So I can rewrite this as x is equal to a c plus b. Now, with b squared minus c squared, we call that the difference of two squares. So the difference of two squares, I'm going to write over here, a squared minus b squared is equal to a plus b, a minus b. So I'm going to use that rule. So instead of a, it's b. Instead of b, it's c. So it will be b plus c, b minus c. C plus b cancels out and leaves me with x is equal to a over b minus c. Let's look at the next question. So the next question we've got is x plus a over b. Take away 2 is equal to x minus b over a. So the first thing I've done is made the 2 into a fraction. We want it to be b. So that means 2b over b is the same as 2. This allows me to go into the next step. The next step is I can make it one fraction by saying it's take away 2b. This gives me the option of getting rid of my fractions by timesing both sides by b and both sides by a. Before we can do anything more, we need to expand. So that means a is being times by everything inside my brackets, and b is being times by everything inside. So now I've got ax plus a squared minus 2ab is equal to bx minus b squared. The next step I need to do is I would like to get all my x's onto one side, and I would like to get everything else onto my right-hand side. So to do that, the first thing I'm going to do is get everything onto my right-hand side. So I'm taking away a squared, and I'm plussing 2ab to cancel these parts off. If I rewrite that, I'm just left with ax on my left-hand side. Do I have any x's left on my right-hand side? Just one, so I take away bx. That gives me ax minus bx. So one of the things I can see here is this looks similar to one of our rules. So I'm going to reformat that in a minute. But on my left-hand side, I can factorize out the x and then divide by a minus b. So this is looking almost done. The only thing I want to do first is I want to factor out the negative on top of my numerator. So if I do that, I'm going to be left with b squared minus 2ab plus a squared. That connects into a perfect square. So when you think about the perfect square rule, I've got a minus b squared is equal to a squared minus 2ab plus b squared. And that's what we've got here. A squared minus 2ab plus b squared. So that tells me I can change them and have them as a. So I'm going to rewrite it as b minus a, b minus a. Now, at the moment, it still doesn't feel the same in my brackets. So what I can do, I can factor out a negative there. Or another way is I could put the negative into one of my brackets. If I do that, then straight away I've got negative. The negative apply it to the b and apply it to the a, and it becomes negative b plus a. Negative b plus a is the same as a minus b, and that can straight away be cancelled out. And, oops, I've got eraser. And that leaves me with x is equal to b minus a. Now we're going to get a bit trickier and look at simultaneous equations when we're dealing with equations. So it says solve the following simultaneous equation for x and y. Lots of these I personally find substitution easier, but in this case here, I can clearly see that I'm able to get rid of ax. So I'm going to use elimination. I'm going to line my two fractions up, and I'm going to take away ax, take away ax, cancels out. Bx minus negative bx is turns into positive, so it's 2by. And then I've got 4ab, take away 2ab is 2ab. That gives me an equation. The next thing I want to do is get y by itself, so I divide by 2b. The 2 and the b cancels out, and it gives me y equals 8. I'm now just going to substitute y into one of those equations. Same thing that we would normally do. So I've picked one of my equations, the first one. Wherever there is a y, I put a. Now I'm going to solve for x, which means I'm going to take away ab. 4ab take away ab is 3ab. And then I have to divide by a, and it gives me x is equal to 3b. We'll do a couple more. So this one here, we're going to solve the following simultaneous equation for x and y. So we've got two equations here. Now, these look a lot more complex, and I struggled in terms of seeing if we could use elimination. So I found substitution was easier, so that's what I've used. So that means I'm going to write down one of my equations here. I've got b plus c in brackets y plus ax equals negative ab. So the first thing I'm going to do is get x by itself, which means I can see I've got this term here, so I will take that away. That gives me ax is equal to negative ab minus, in brackets, b plus c times y. To get x by itself, I just divide everything by a. That gives me this equation here. The next step that I'm going to do is I'm going to, like we did before, grab this and substitute this value into my other equation. So I've got my other equation here, a plus b in brackets x plus cy equals bc. So wherever I see an x, I'm going to place this. So it looks a bit complex when I've got those two brackets, but we just need to think when we've got a suffix next to a bracket, it's times in by the numerator. So I'm just going to rewrite this, but have it in terms of being on top. So now I can visualize it. It makes it easier to see. So the next step that I will be doing is expanding this inside bracket. So that means I'm going negative y times b times c. That gives me negative by and negative cy. Just makes it a bit easier to visualize. The next step that I like to do is I would like one fraction. So that means this cy here, I'm going to turn into cya over a, because times the top and the bottom are the same amount, but it means it's going to be one fraction. So I can make it one fraction. Because I've made it one fraction, it makes it so much easier to deal with this, because I can then times both sides by 8, and I've got no fraction. So now I've expanded the top and I've got rid of my fraction. The next step that I'm going to do is look at what I can see. So at the moment, I've got negative a squared b and negative ab squared with no y. So I'm taking that to the other side. The next part that I'm going to look at is, can I simplify anything? So straight away here, I've got negative acy and plus acy. Those instantly will cancel out. So it's just trying to simplify it. Now I'm left with something a bit easier to look at. Negative aby minus b squared y minus bcy is equal to bca plus a squared b plus ab squared. Well, everything on the left-hand side has y. So the first thing I will be doing is factoring out the y. Now I've factored out the y, I'm going to divide by everything in that bracket, and that gives me something a bit easier to look at. To see if I can simplify it further, I'm just going to look at, is there anything common on top, and is there anything common on bottom? So straight away here, I can see I've got BA, 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 and BA. So if I'm going to take out the BA on top, likewise, I'm going to take out the negative B on the bottom. If I do that, I'm left with A plus B plus C in brackets. I'm also left on the outside with a B that I can cancel, and this I can cancel. So that gives me the Y value of Y equals negative A. Now, because I've got y equals negative a, it means I can substitute that back into my formula for x to simplify my x value. So this is why it's a bit messy. That means I'm going to substitute that value back into my y value, which I've done here. And now I'm just going to expand. That means I'm going to have negative a times b and negative a times c. I'll keep the brackets there for now. With now I'm going to apply this negative with everything inside the bracket, and it's going to turn positive. Now I can see that straight away here, I am able to simplify one more. We've got negative AB plus AB. That instantly cancels out and leaves me with AC over A, and then I can divide both and cancel out my A's there, leaving me with X equals C. So it's now looking a lot easier to look at. The final question that we're going to do, we've got AX plus BCY is equal to C, and we've got BX plus ACY is equal to C. So again, looking at my two equations, I struggle to be able to cancel out. So I am just going to use substitution. So I'm just going to pick one of my equations. Now with this equation, I'm going to get X by itself. So the first thing I would have done is taken away BCY. That leaves me with AX by itself. And the next step is I would divide everything by A, and that gives me X by itself. The next step is substituting the X value into the equation. So I'm going to pick my equation that I've got. So I've got BX plus ACY equals C. Wherever I see X, which I've got here, I'm going to put this value in. Again, it looks like a pain, so we can simplify it. Remember, when we got something next to a fraction, it times us with the numerator. So this helps me out. The first thing before I do anything, I'm going to do two things. One, I'm going to expand my brackets. So B times C is BC, and B times negative BCY is negative B squared CY. The other part I'm going to do is I'm going to make this over 1 and times my denominator and numerator by A to make it a fraction. Now it's a fraction, it makes it easier because I can group them into one fraction. So the next step is we need to get rid of the fraction. So we're going to times both sides by A, and that will mean on the right-hand side, we'll have AC or CA, same thing. Next part is we want our y's to be on the left-hand side. So I'm going to take BC away, and that leaves all my terms on my left-hand side with y. That means I can factor it out, and I'm left with negative b squared c plus a squared c is equal to ca minus bc. Because I've factored y out, I can divide everything by that bracket. So that gives me ca minus bc and negative b squared c plus a squared c. Now I'm going to see if I can simplify that. So the first thing I can see is I can take out the c. So if I factored out the c, I'm going to have negative b squared plus a squared. Now if I rewrite this inside here, that is also going to be a squared minus b squared. The c's are going to cancel out. That will leave me y is equal to a minus b and a over a squared minus b squared. This is why we really need to know our rules. The difference of two squared rule, a squared minus b squared is equal to a plus b, a minus b. So I'm going to put that into my rule. And now I've got a minus b over a minus b and a plus b. The a minus b's cancel out. That leaves me with a 1 on top over a plus b.